Currently, I am working as a head of faculty at NIT. Today, I will teach you one very important topic, cellular automata, which is related to artificial light simulation. We call it as a CA also. Actually, automata is a plural, and in singular form, we can say that it automation. Okay. And we call it as cell. Now, what is the device is required? The person basically I will divide entire lecture into two sections. In one section, I will give you a little bit introduction, characteristics, as well as properties. And the second section, I will give you some example and some is real life. Basically, it is used for generation in different type of solutions, unique solutions. In this case, we start using cell. This is a basic unit, cellular automata, and cell is the basic unit which we use representative unit, certain type of cells. Like here, I am using square cell. I can use triangle cell. I can use hexagonal cell. These all are cells. Okay. The property of cellular automata is it is discrete. Why it is discrete? Because the state of cellular automata will be discrete. It is a finite state, finite discrete. Suppose that there is two states. I am representing using 0 and 1. And suppose let us take the minimum combination of cell. I will say 1D cell. It will be L. Okay, like this. I can do 0, 1, 0, 1, 0. But this is just not a logic. There should be some. Each cell will depend on its neighbor cell, the transition. So basically, there are two things. One is what is my current state. Current state. Second thing is the next state. Next state will depend on some transition. It depends on the neighbor. Neighbor states. Okay, let us take example. First, I have already explained what is here. One thing is mesh. It is a combination of cells. Like this is 1D mesh, I can say that. And we can have like this square matrix. Okay. If I am doing 1, 2, 3, 4 up to some values 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each cell has 16 states. So in this case, I can represent state using S1, S2 up to Sn. As you can see, in this case, total 16 combinations, so total state will be 16. This already I defined what is current state. So if you are referring this example, in this case 0, 1, 0, 1, 0, 1, therefore each cell can have two states, either 0 and 1. Same thing now, the another thing is transition. How the cell state will change, it will depend on what is my current state plus what is the status of my life. So the very famous game is game of life. Game of life. What is game of life? In this case, there are cells. One cell. Cell can have two states, either alive or dead. And dead. I can represent it with alive 1 and dead 3. Even I can give color black and blue. So let me explain by using two color. I have two color pointer. I will explain this thing. Suppose I am drawing this type of mesh circuit. Okay. This is the grid. You could see if it is my current node is here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. And my current state is X. Now I need some transfer node. Based on this one, I will find my current state of this one. I have defined 3 loops, 4 loops. And it is all biological inspired, all nature inspired. First one, if current node state is 9 or 1, or I am representing using blue color, like this is my current state. The next state will depend on the condition. So I am giving 3 conditions, 4 conditions. If more than 3 is alive, so this is the condition of overcrowd. So my state will immediately die. Okay, one condition. Second, if less than 2, in this case, this is starvation and loneliness also we can say. Loneliness or starvation. In this case, it will again die. The only condition in this case, the node will survive again, is that when I have 2 or 3 neighbors live. Okay. Third thing, it might be possible that this node is not live and this is live node. The live node is again become live. Only condition is that if there is 2 or 3 node, minimum 3 node is live, then it will become live. Now let us explain this concept here. In this case, 8 neighbors are there. Out of 8 neighbors, if you see out of 8 neighbors, 1. So the next state of this neighborhood will follow this one. Either 2 or 3 neighbors is live, so it will remain in the live state. So in this case, I can represent to you CST plus IT. Okay. The next state will be, it was live, it will again live. If neighborhood is generally we represent automata using as I and R. R is the neighbor condition. This is my current state and this is my answer. Let us take this now. Suppose this is my node type, because this grid can be extended up to any time. Just suppose that this is my node. Okay? Current node. The current node is black, so it is not in live state. If you see, the neighbors are 1, 2, 3, 4, 5, 6, 7, 8. Only one neighbor is live. So the condition is that if the state is there and at least 3 nodes are live, then become the live. But in this case, the node only one neighbor is live. Yes, all are dead, so this node will not become live. But let us take example. Now this node is live and this node is live. Now you see 3 neighbor nodes are live, so it will become the live in the next system. Simply we take example as example is the fish example. The fish example is like that you are using some logic like this. Breeding rules record. Simple rule is that if it is a like this way. If one piece is here, this is my current state, this is magnetic, and one piece F, another piece F. If three neighbor pieces are there, so braiding will take place, and at least out of three are two are nature, so this state will become nucleus will take place. But suppose the scenario is like this, only one is in the neighbor of this current state. So again, instruction concept will arise, no piece braiding will take place. Okay, so it will remain in that state. Let us take example when more than three pieces are there. In this case, overcrowded, other piece will die in that state. Even piece was here, and four pieces are in the neighbor now, then it will die. This is the basic rule which we use during cellular automata. Cellular automata can use for many applications. Can use for the finding random solo random number generator. For each time, randomly you can find different generation of the key, and that we can use for public private key, we can use for password protection, and many other applications this can be used. Last I am going to discuss one thing in ahead, that is fuzzy. Fuzzy say that fuzzy logic based cellular. In this we have made membership function. The value of membership function will be 0 and 1, and then x will have certain value. Fuzzy in that it is trying to capture the fuzziness available in the environment. Okay. So simply the rule will be that we have states. We have only one things which we can do here. We can do something transition. Transition based on fuzzy. Either it was 0 and earlier it was 0 and 1 logic, but now it is 5 logic. We are doing, and I can define some rule here, which I have already written for you. We can check. Okay. The membership function I will calculate to you. The function equal to 0, 1, e poverty, e max, e minimum upon E max minus E minimum. The condition here is for when maximum probability, minimum probability. When probability of current state is less than minimum probability, in this case we will have numbers function 0. That means and beginning state is 0. Another state would be E minus E minimum. In this case, when E minimum is less than P, so the P probability between P minimum and P max. In this case, I will use this as a state. To find the state, I will use this formula. And if it is greater than P max, in this case, I will use. So this is simply fuzzy model, which is fuzzy model. And another thing, this is also very sensitive, because so far we are using deterministic logic, either 0, 1 and finite number of states, but we can use for the Markov process or Markov field. Markov process and field. This we know is so much that is based on probability. So we need to calculate the probability. So simply we will find the probability of, if I am state as I am going next state, so there should be some probability which we can represent as I j. So Markov process, if I have total 4 states, so I will get 4 plus 4 matrix. If I have any state, I will get n percent. And each state I will define 1 state of probability as 1 P11, P12, P13 up to P1 and Pn1 to Pn. So I will get the probability of each state, and based on this one I will determine my root. So simply the sum of each row will be n. So you can say that j equal to 1 P I j. Okay, and the transition rule will be P I j already I defined. expecting some people